Okay, hello, this is Dr. James, and today I was going to do some experiments on electrolysis. I was motivated to try to find an electrode material for producing heavy water. Basically, when you do electrolysis on water, there's some deuterium in the water, and it's mostly protium, or protium is a single proton, and then deuterium is a hydrogen with a proton and a neutron, which can be used for fusion experiments and other nuclear experiments. It's very interesting. I know the Germans got heavy water by doing lots and lots of electrolysis, and my experience with doing electrolysis is that it always chews up the electrode. So I was looking for an electrode material. Typically they use platinum. Platinum's very expensive. I was looking for a cheap substitute for platinum, and here are some of my experiments. I didn't find the answer to that problem, but I did. It's always interesting to see how different materials behave under different circumstances, and so I was kind of surprised. I tried lots of different materials, and some of the results were unexpected. So if you're interested in just seeing real experiments, because it's really hard to find stuff that's real anymore, especially on the internet, because it's totally censored. And I can't say why, because we are under a totalitarian communist takeover the world. Anyway, so if you like real stuff, let's see, what was it? I mean, my friend was telling me he was watching a YouTube video where someone supposedly threw cesium into the bathtub, and the bathtub exploded, and then someone proved that they were just putting explosives in the bathtub. So the video that was fake got like millions of views. The person who proved that they're a bunch of liars, got like tens of thousands of views, if that, because I guess people like fake stuff. But I try to do real stuff, and you can see all my wonderful stuff in the background. And anyway, here's some real experiments that you probably wouldn't see anyplace else if you're interested in electrochemistry or other things. And I didn't know the answer, that's why I did the experiment. And so if you'd like to see these different materials under electrolysis, and I use pretty much sodium hydroxide for the electrolyte. And I like that because it doesn't go away. If you put like hydrochloric acid in there, the acid will be disassociated, and it'll put a lot of HCl in the air and stuff. But hydrochloric acid, or sodium hydroxide, will always stay in the solution. It will always it has a sodium and then the hydroxide radicals. And the sodium can't evaporate away, and as you electrolyze the water, it will make more hydroxide radicals. So you'll basically, like if you put sodium chloride in the water, the chloride would eventually go away, and it would become sodium hydroxide. Sodium hydroxide is the basically end result of electrolysis, and so it's a pretty much stable molecule that will stay in there. And so that's why I used that, but maybe it wasn't the best choice. I don't know. I'm still thinking about these experiments, but I just figured I'd share these with you because I do a lot of experiments, and I like science, and I figured if you like science too, you might like to see, well, let's say silicon. What happens when you try to make silicon electrodes? Because I thought they would be, indestructible silicons, a group 4 element, and the results are really unexpected. So anyway, let's get started. We'll do some electrolysis and see what happens. Okay, so here's electrolysis with some silicon plates, and even though I'm putting full voltage on them, it doesn't seem to be generating a lot of gas or a lot of bubbles. Maybe it's because there's some kind of oxide layer on the silicon plates. I put quite a bit of salt in there, and it doesn't seem to be evolving a lot of gas here. It's kind of disappointing. Okay, so here I have 2 pure nickel wires on there. I'm trying different elements because I put iron in there, I know for sure that the iron was breaking down by the oxide, on the oxygen side. It was destroying the iron. It looks like the nickel might be breaking down too, because I'm seeing green stuff forming at the bottom, but it's really doing electrolysis very quickly now. See that? Looks like there's green stuff on the bottom. So I think I'm looking for an electrode that's hopefully not going to corrode on the oxygen side. The oxygen side's the positive side. Okay. Okay, so let's try putting the silicon on the oxygen side. And there's no gas involved when I do that. So the silicon is definitely inert, but it's not working good as an electrode on the positive side. So I guess that's not good. Okay, so here's tungsten electrodes. And it looks like they're bubbling away. I wonder if I could put it up on higher current. Okay. Okay, so it's been running for about a day here. And it looks like there's no more bubbles anymore. And if I take these rods out, it looks like some kind of oxidation layer has formed on the positive electrode here. And that seems to have stopped the reaction. So even though it didn't disintegrate the rods, it seems to have stopped working. Okay, I tried reversing the rods. I put the one with the oxide layer on the minus side now. And let's put them in there and see what happens. It'll look very interesting. Looks like it starts to electrolyze again. And now both sides are oxidized. Okay, so here I have a couple electrodes made out of aluminum foil. And let's stick them in the water. And that one really seems to bubble a lot. Look at that. Wow. That's like crazy. Okay, I guess I'll let that run for a little bit. And we'll see how that turns out. Okay. Wow, look at that. Just take a look at the other electrode. Looks like chunks of aluminum are floating around in there. Water's turning all gray. Holy cow. It's drawing so much current. I don't know if you can see steam coming off of that. And the wires are getting hot. I might have to pull these out and give them a break. A little bit, might need thicker wires going to this thing. Looks like it's almost eating the aluminum off the positive electrode completely. I can feel steam coming off of this. Wow. Unbelievable. Okay, so I ordered some titanium rods to try some more electrolysis experiments with, and I didn't realize, I guess they're 3 feet long. And well, here we go. Let's try to open this thing up and we'll take a look at the rods. And yeah, I might have to cut them down or something because this is a little bit too long, you know, to fit into our experiment over here. Okay, again, here's our case here. And let's cut this. And let's take a look at this. These are our titanium fill rods. Oh my gosh. And, wow. I'd like to not cut them and just do the experiment, but I'm afraid they're going to short out or something. Well, I could just take 2 of them and see what happens. Might need some fresh water because that aluminum really murkied up the water. The water was boiling when I got done with that guy. Look at that. Oh, what a mess. What a mess in there. Maybe I'll get a new container. Okay, so now I have my battery hooked up to the titanium rods, and let's stick them in the water with salt. And let's take a look down there. See if we see any bubbles. I think I might see some bubbles. There's some bubbles coming up around the hydrogen. Hydrogen one is on the left-hand side, and the oxygen one's on the right-hand side. Looks like it's bubbling, but not a super lot. Here's it. Let's take a look here. Looks like it's forming an oxide layer on the oxygen side. It's becoming discolored there. Okay. Stuff all the way. Oops, I don't want to let those electrodes touch together because that's not good. Okay. Doesn't seem like it's forming a lot of bubbles though. I suspect maybe it's going to form an oxide layer on the oxygen side, and then maybe the reaction is going to stop. In fact, I don't really see any bubbles anymore. That's what happened with the tungsten ones, is that I put them in there and they formed bubbles for a little bit and then they stopped. It's definitely not very many bubbles though for what it should be. Okay. Okay, let's look at these electrodes under our magnifying glass. Doesn't seem like it's focusing on it. So it looks like the hydrogen one is a little bit lighter. I'll just put some reference paper back here. Hydrogen one's a little bit lighter where it was under the water. And let's see if that makes it better. And the oxygen one, which is the lower electrode, has some kind of oxide layer forming on it, which is probably not a good sign. Okay. Okay, I gotta tape the rods apart so that they don't touch, because that was sparking and burning the rods up. Really causing a lot of problems. We'll look for bubbles in there. I'm not really seeing a lot of bubbles. Not like some of the other rods, especially aluminum was really good, but it was definitely destroying the aluminum as it ran. So I'll let this run for a little while, but I think that this is probably a non-starter here. Titanium forms the oxide layer, it looks like, and it prevents the electrolysis from happening, prevents current from flowing. Okay, I've been letting this run for quite a while now, and I'm not seeing really any new bubbles forming. I think it just ran until it formed an oxide layer on the electrode on the left-hand side, the oxygen one, which is the positive, and the reaction stopped. So I think we'll move on to our next victims, our next test materials. And we'll take this dangerous thing apart. Okay, so here is a pair of stainless steel bolts hooked up to our battery. Let's give this a shot. And those produce quite a bit of bubbles. Look at that, wow. What the heck? It's producing some kind of yellow stuff coming off the electrodes. That yellow stuff looks like it's going down to the bottom. Oh, what happened? It stopped producing electricity? Or bubbles? That's weird. Huh. Okay, I guess it's some kind of weirdness with the battery charger. It needs a voltage on there for that battery, for the battery charger to work. This is my battery charger I got from Harbor Freight. I don't know, sometimes it just kicks off. Let's put it up all the way. Put it up to 50 amps. Let's see what happens. Okay, so here's some more weirdness. See, I have my voltage probes on there, and it's reading 13 volts. But as soon as oh shit, the probes came off. Okay, so it's reading 13 volts. But as soon as I put this into the solution, oh no, it's freaking going crazy over here. Okay. There we go. Look at that. That's going pretty fast. Oh, okay. Well, maybe I'll let that run for a while and see how that works out. Very cool, huh? Oops. Okay, so that is stainless steel. It's turning the water all disgusting. Okay. Very cool. black now. Wow. Oh, of course we should probably test for some hydrogen, right? Let's see if we got any hydrogen in there. Definitely sounds like some popping going on. Very cool, huh? Science is so fun. Holy cow. Let's see. These wires are getting hot. It looks like it might be corroding the oxygen electrode. I'll let this run for a little bit longer. I see smoke coming. Very cool. Okay, maybe I better turn that off because the water is boiling now. Let's take a look. Let's see. Oh my god. Oh, the tape is all sticky and disgusting. Holy crap. Look at that. Oh my god. So black stuff is forming on the hydrogen electrode, and the oxygen electrode looks like it is getting worn away. Wow. And the water is smoking. Holy cow. Okay, so we're going to run this some more. I had to shut it off because it gets too hot. The water starts boiling. But it looks like it's eroding the positive electrode, the oxygen electrode, and I don't want that thing to break off. Okay, anyway. So, and I was hoping it would be easier to separate the water from the sludge, but it looks like it is creating just a total mess. Look at that. The sludge is not settling, it's just going all through the water. I wanted to do some experiments with that too. But it seems like the electrodes are holding up better than a lot of the other ones I've tried. And, you know, stainless is relatively cheap. And they're not forming an oxide layer and stopping working, that type of thing. So it looks like this might be a good way to do electrolysis. I'll try some other materials too. Okay. Okay. Oops. Definitely some hydrogen coming up. Very cool, huh? Okay. Okay, here we go. I run it some more. Let's see how the electrodes are doing. So it's definitely, wow, look at that. Definitely depleting the oxygen electrode. And the other one's getting coated with disgusting black stuff. And it looks like it's not going to be super easy to separate the water from the sludge, because look at that. Oh my god. It's unbelievable. Here, let me try something. Actually, I have an idea. Okay, so now we're going to talk about a different type of electrolysis. This is just going to use one electrode, and it's a chemical reaction. And what We're going to use aluminum. Aluminum has a huge amount of energy density. It's able to pull oxygen away from about everything. Aluminum is used in thermite reactions, and it usually has. Let's take a look at aluminum. I have a piece of aluminum foil here, and it's usually protected by a thin oxide layer around it. But if you remove that oxide layer with something like sodium hydroxide, then this can react with the water, form aluminum oxide, pull the water out of there, and give you hydrogen. So it's a great way to produce hydrogen if you don't want to have oxygen, if you just want pure hydrogen. Let's take a look and see if we can get this to work, okay? Okay, so I have a mason jar. I wanted to get something clear so you can see through it better, with reverse osmosis water in there. Let's clear this up a little bit. And here is some InstaFlow. And the active ingredient in here should be, well, sometimes they don't put the active ingredients anymore, but it should be sodium hydroxide. Okay. Sodium hydroxide. See that? It contains sodium hydroxide. So let's, I probably shouldn't even handle this with my hands. Let's see. Come on. What the heck? Got some plastic melted onto this little plier things here. Oh my god, they must have got hot. Anyway, let's take a look in there and see if we can grab out some sodium hydroxide and stick it in the water. Okay. Looks like it's all clumped together. Probably want to use safety goggles. You don't want to splash this stuff in your eyes either. It'll probably burn out your eyes. Okay. And sodium hydroxide is very caustic, very strong base. Not sure why it's not dissolving. Oh wait, I think it's starting to dissolve. I think I did a video before where you put it in the water and it would produce a lot of heat because there's heat released when the sodium hydroxide dissolves. Let's see. Yeah, see it's starting to fizz, plop, plop, fizz, fizz. This is not Alka-Seltzer though. Okay, I think I'm going to put some more in there. And then we will test this out with the aluminum foil and see if this stuff will eat it up and produce some hydrogen for us. Should be very cool. Okay, it was making some noises in there while it was dissolving. Let's, just out of curiosity, I got my pH meter thing. Hopefully this thing still works. Oh my god. It's been a while since I've used it. Ooh. Let's see if this thing turns on. Okay. Okay, it seems the battery was dead. Let's try this now. See if we can measure the pH in here. That doesn't seem too good. think this thing's working. Just give me random numbers. Okay, that's no good. Okay, so let's just give this a try, I guess. We'll see if this is working. Okay. Okay, let's try adding a little bit more sodium hydroxide and get that all mixed up. Okay. Okay, so I added a whole bunch more sodium hydroxide in there, and it kind of warmed up. It gets a little bit warm when you do that. And let's just try this again. See if we can get the aluminum to dissolve in there. See some bubbles coming off of it. Oh, look at that. See the bubbles coming off? It's eating up the aluminum. Oh, very cool. Look at that. That smoke's coming off. It's eating up the aluminum. Holy cow. Very cool, huh? Let's see. Maybe I can get it over closer to the edge so we can see the bubbles coming off. Look at that. Producing lots of hydrogen. You know, since electrolysis is going to destroy your electrodes anyway, why not put something in there that you don't care if it destroys it? The energy source is aluminum. That bubble's coming off of that. Holy cow, that thing is smoking. Okay, see if we can see it better here. Huge amounts of bubbles coming off as it destroys the aluminum. And it is smoking, look at that, oh my gosh. Very cool, huh? Okay, I was just curious about the electropotential of this reaction. So here I have a graphite welding rod, and I have it hooked up to, I guess, yeah, white is the positive. So I'm going to put that in our sodium hydroxide solution. And then here's our aluminum electrode. I'll stick that in there. And see, it is producing lots of bubbles. And let's see what kind of voltage we're generating. Looks like 1.2 volts. Oh, very cool. Okay. Just let that hang in there. Yeah, oh, 1.3 volts. Wow. Okay, just curious about the potential. So So I really wanted to generate hydrogen, so it looks like we are definitely generating lots of hydrogen in there by destroying the aluminum. And no power needed. In fact, it generates power. Look at that. I have to see how much current this thing's generating. Just out of curiosity. Very cool, huh? Okay, so here's the chemical equation that we're looking at. So the aluminum combines with the sodium hydroxide in the water to give off hydrogens and create the sodium, what is it called? Sodium aluminate, okay, which is highly soluble in water. Okay, so all the byproducts will be either soluble in water, it destroys the water because it takes 6 waters and it gives off 6 hydrogens. So it's going to produce a lot of hydrogen and a lot of water-soluble salts with aluminum in it. So very cool reaction. Okay. Okay, wow, this time I put a lot of aluminum foil in there. And it looks like it is really doing a lot of electrolysis here. Holy cow. Freaking container's getting hotter than hell. Holy crap. Maybe I put too much in there. I hope this thing doesn't explode. Holy crap. Look at that. Let's see how hot this thing is getting. 38, 36, 37. Down the side, oh, 50, 60. Holy cow. That's pretty hot. I'm afraid to strike a match. Oh man. Boom. Holy shit. Oh wow. Holy cow, look at the hydrogen coming off of that thing. Wow. Very cool. Lots of hydrogen coming off. Holy cow. Maybe I put too much aluminum in there at once. Might be able to use this for extra power, huh? Okay, so here I have a couple of graphite electrodes. Let's just stick them in our salt water here. And we'll see how these work. Okay, look at that. Producing lots of bubbles. Okay. And we'll see how these electrodes hold up. Got our battery charger back there. And I'm trying to make sure they don't short out. Oh, come on. Okay, so yeah, look at that. Wow. They're producing lots of bubbles. Okay, so we'll let that run for a while and see how that turns out. Okay. Graphite electrodes. Actually, I wonder. Oh, anyway, bubbles are too small to make a popping sound. Okay, very cool, huh? Okay, looks like after running one day, it's done a lot of electrolysis. It looks like I ate off one of the electrodes because this one was touching the bottom. And that's typical. It seems like the oxygen electrode gets eaten up. And that's even true with carbon. Wow. Okay. Very cool, huh? The graphite electrodes seem to be working pretty good. They left a lot of graphite on the bottom. Okay, so the graphite electrodes are definitely destroyed when you do electrolysis on them. Lots of graphite. I have to keep on replacing them. Okay. Okay, it looks like it's finally arrived. And let's just take a look at what we got here. Try cutting this thing open. Let's see what we got inside. There we go. 1 foot of gold wire. Very cool. Although it doesn't look like a foot long, does it? Is it a foot long? Look at that. Maybe it is. Okay. We'll have to try this out in our electrolysis experiment and see how it works. Very cool. Okay, so here we go. I'm going to try this experiment with, I think I'm going to use a tungsten rod. I was thinking gold and gold, but let me just try. Oh, I don't want them to touch together, that's for sure. Maybe I'll grab this a little bit higher. Okay, so we have the gold wire in there, which is kind of expensive. Oh, come on. Let me get it in there. Okay, so the problem I've been having so far with the electrolysis, look at that, Jesus, I may have to use a different thing then. So it seems like I could use almost any electrode for the hydrogen side. It didn't seem to have a problem. It was the oxygen side that was disintegrating, and oxygen chews up just about anything. So I chose a metal. There's 2 metals that I know of, possibly more. The noble metals, I guess platinum, palladium, rhodium, whatever, and well, gold don't have an oxide state, as far as I know. They are noble metals and they don't react with oxygen, and so oxygen is negative, so it should be attracted to the positive electrode, and hydrogen is positive, so it should be attracted to the negative. So that's kind of weird. I just stuck it in the water and the tungsten looks like it's already getting corroded. So gold can combine with chlorides, and so I was very careful to put reverse osmosis water in there, and I'm not going to stick sodium chloride in there because it will produce chlorine gas, which will probably dissolve the gold. We'll just use sodium hydroxide and see if this will keep our electrode intact. I'd like to have a low maintenance electrolysis machine. And might take a while for the sodium hydroxide to dissolve. But I definitely don't want to chew up my gold. The idea is to get an electrode that will last, hopefully. And let's take a look in there. Okay, it might take a while for the sodium hydroxide ions to get through the water, but hopefully this solution will work. It could be that I have to use something other than tungsten, because it looked like that one got all corroded when I stuck it in there. Okay. We'll let it sit for a little bit, and if it doesn't work, I'll try changing out the electrodes and see if I can get that to work. Okay, let me just check to make sure there's nothing wrong with our setup here. I disconnected the negative from the gold. This is 24 karat gold, by the way, pure gold. And let's just put the carbon electrode in there. See if it does anything. And it's not doing anything. There's a problem with our wiring or something. Let me troubleshoot this. Okay, I was using my voltmeter down there to measure the voltage drop across these clip leads, and it seemed like the red one had a very large voltage drop, so I suspect maybe the wires were almost burnt through. Let's try this. Okay, there we go, look at that. Okay, we got that hooked up to the gold, and it looks like we're getting bubbles off the gold electrode and the tungsten. Very cool. And I'm going to run this for a while and make sure that we don't burn the gold electrode up, but I think it should be safe as long as we don't have any chlorine ions in there. And I'll try to keep this solution as pure as possible. Okay, very cool. Look at that. We got our gold and tungsten electrolysis going. Awesome. Okay, so we'll let that run for a while, and we'll see if it chews up the gold or not. Hopefully it doesn't, because those were expensive. That was a pretty good price, $140 worth of gold there. Okay. Okay, let it sit, and I think the sodium hydroxide has dissolved a little bit more, and it looks like our electrolysis is going pretty good now. Look at that. Oh, isn't that beautiful? Hopefully, hopefully the gold electrode, which is the gold electrode's on this side over here. This is the left-hand side, and the tungsten is on the right-hand side, which is over. See if I can come over here. Over here, okay. And so hopefully the gold will survive. I hadn't had a problem too much with, of course, you know, sometimes when you solve the first order problem, the second order problem will show up later. I haven't had a problem with the electrode on the hydrogen side breaking down yet, but maybe if I get a really good oxygen electrode like the gold one, so I can run for a long time, maybe we will see what the limits are on the hydrogen side also, because I think hydrogen can embrittle things, and well, we're doing some real material science here. Look at that. Oh, this is so awesome. Of course, there's my power supply in the back. Okay. Very cool. Well, this doesn't look like a good sign. Looks like the water is changing colors. Oh my god. That's not good at all. Let's just stop this reaction. Take a look here for a second. What the heck? Oh my god. It's really hot. Okay, well, I don't know. Let me try pulling this electrode out and see if it's destroying it. Do this tape here. Holy cow. Look at that. Oh my god. It's so thin. It's eating off all the gold around it. Let's see if we can. Okay, let's look at this. Oh, I think I found a way to make gold oxide or something. Jesus Christ. Look at that. It's pretty much eating all the gold off. It's made it super, super thin. Okay. this is a very expensive way to not do electrolysis right. Let's see if I can get that on a white piece of paper background. Okay, so there is a normal gold thickness up there, and this is the part that was under the water, and it is super thin. And oh, looks like the water has turned all brown. So my theory did not work. The electrolysis is, the sodium hydroxide is chewing up the gold, eating that electrode as well. This is really bad. Okay. No good. Okay, let's take a look at the hydrogen electrode. Is it getting gold plated? You freaking kidding me? Unbelievable. Look here. Let's change this down. Is that me? Or does that look gold on the tungsten? I think the tungsten's getting gold plated. Oh, this is so freaking annoying. Okay, so let me see what I can do about this. Definitely not a good sign. Look at that. Water's all brown. So I guess the oxygen even chews up the gold electrodes. Wow. Holy cow. Here's our tungsten rod. And it looks like gold, doesn't it? Looks like it plated gold onto our tungsten rod. Wow. That is amazing. It really looks like gold. That's not what I intended to do. Wow, very cool, huh? Oh. Okay, so I guess that is the end of our experiment. Okay. So we'll have to try something else. But I guess if you want to plate gold onto tungsten, I think I have found a way to do it. Very cool, huh?